All right, so the next section we're covering is 3.7, and it is called Implicit Differentiation. Now, there are instances where we have situations where what we're dealing with is not a function, but it would be nice to be able to find the slope. And we don't want to necessarily have to change it into some other form of equations, such as a parametric equation, set of equations that we looked at in the last section. So what we can do is implicitly differentiate and find out, and it goes back to what we were talking about with parametrics. Remember that when you find dy dx, that is the derivative. So what we're going to do here is we're going to take the derivative of each one of the terms, and on both sides of the equation, of course. The derivative with respect to x of x squared is going to be 2x. Now, where it's a little different is this part right here. The derivative with respect to x of y squared we can't really take because technically, well, not technically, but exactly, that right there is not an x. What we can do, though, is we can use the chain rule and think of this as blob squared, and then multiply by the derivative of the blob after that. And we end up with y prime or dy dx. I generally always put dy dx because, well, you've seen my handwriting, and my y prime, I could lose a prime real easy. So I always write dy dx. If you want to write y prime, that's fine. Just make sure you don't lose it. Don't lose the prime or mistake it for a y when it's actually not. It's y. It's the derivative of y. And dx of 1, what's the derivative of 1 with respect to x? It's going to be 0. So then what we want to do, once we've used the chain rule here, what we did is we converted this thing to a derivative with respect to x, because that's what we're taking for all the terms. That's why the dy dx is here. Technically, this one right here was what? It was d dy. We took the derivative of that with respect to y. Now, when we multiply by dy dx, the dy's would cancel out, and it's going to leave me with a derivative with respect to x. That's why I have to multiply by that. All right, so now that's just the use of the chain rule. And then all you want to do to find the slope is solve for this. So you're going to move the 2x to the other side, and then you're going to divide by 2y. So we subtract 2x from both sides, and we're going to divide both sides by 2y, and then simplify. We can cancel out the 2's. So dy dx is negative x over y. So the slope of this thing, the slope of this circle right here, at any point along the way, let's say that the point 1, 1 was on here, that would mean that I would plug in a 1 here and a 1 there, and my slope would end up being a negative 1. Well, if 1, 1 is in there, guess what's also in there? 1, negative 1. And that would give me a slope down here. If I plug it in, I'm going to get a slope of positive 1. So this equation right here will find the slope anywhere on that circle. All we have to do is pick a point that's on the circle, plug the x and the y parts in right there, and calculate it, and that's going to give you the slope. All right, so let's do another one. A lot of times what happened, now that last one could have been solved for y. Sometimes you can't solve them for y like this one. This one can't be solved for y, but you could still find the derivative, the dy dx, the slope, by implicitly differentiating. So we're going to take the derivative over here, and we're going to have 2 dy dx, because 2 is the derivative of 2y with respect to y, and I multiply by dy dx to change it into a derivative with respect to x. Right? Equals, what's the derivative of x squared with respect to x? Well, just 2x. No dy dx. The only time I put the dy dx is when I'm taking the derivative of a y part. So the derivative of sine y is going to be cosine y, and I have to multiply by the dy dx. All right, now looking at this, you're thinking, well, okay, well now I've got a dy dx over here and a dy dx over here. Well, all you're going to do is you're going to move everything with a dy dx to one side, doesn't matter what side, by itself. So to get just dy dx terms, I'm going to move them over here. So you're going to have 2 dy dx minus cosine y dy dx is equal to, and the only thing that's left on that other side that I didn't move was the 2x. And that's just going to hang out over there. So now, remember, we're multiplying by dy dx, and we're multiplying by dy dx. So we can think of that dy dx as a factor of each one of those terms. So we have a common factor of both of those that we can now factor out. So we get dy dx. If I divide it out of this first term, I'm going to get 2. If I divide it out of the second term, I'm going to get minus cosine y. So now, to solve for dy dx, I'm just going to divide both sides by the 2 minus cosine y. So dy dx is equal to 2x divided by 2 minus cosine y. So there is my slope at any point along the way for this curve right here. But that's how you would go about doing it. Now, this technique is called implicit differentiation. And the way you do it is you're going to differentiate both sides with respect to x. And then you're going to solve for your dy dx. All right, so let's find dy dx for the equation y squared equals x. I want you guys to try it. I'm going to count down here and pause it. And then right after I pause it, I'm going to put the whole solution up here. So you guys pause it before I finish my countdown. Try it on your own, and then you can come back and finish looking at the problem and see if you got it right and see where, if you got anything wrong, where it happened. All right, so my countdown is going. I'm going to finish solving this thing in 5, 4, 3, 2. All right, so there's the solution. You've got y squared equals x. You're going to take the derivative of both sides with respect to x. So you get 2y dy dx, because I'm taking the derivative with respect to y there for this part. Multiply by the dy dx to convert it. Equals, the derivative of x is 1. And then I'm solving for my dy dx. So I'm just going to divide both sides by 2y. So dy dx equals 1 over 2y. And that means that my slope is only dependent on my y value. There's no x here, so I can go left and right, and my slope's not going to change. It's when I go up and down that my slope is going to change, because my slope is dependent only on the y value. All right, let's do another one. Now, with this one, I'm going to count down, but you don't have to actually go try it unless you just want to. This one, I'm going to give you a little hint here. Don't forget the product rule with the x times the y. Now, if you want to stop and pause and you guys give it a try before I work it out, I'm going to start showing the solution in 3, 2, 1. All right, so what we're doing here is we're going to take the derivative term by term. Over here at this part, we're going to have to use the product rule. So derivative of x is 1. The derivative of sine y is going to be cosine y. And since I'm taking the derivative with respect to y, I've got to multiply by my dy dx. And then over on this side, remember the product rule, first times the derivative of the second. What's the derivative of y with respect to y? 1 times your dy dx plus second times the derivative of the first. Well, what's the derivative of x with respect to x? Just 1. All right, so we've got 1's in there we can get rid of. We end up with 1 plus cosine y dy dx is equal to, that x can go away, so we end up with x dy dx plus y times 1. The 1 can go away. And you want to group all of your dy dx terms on one side and all your non-dy dx terms on the other side. So I'm going to move that 1 over here. I'm going to move that x dy dx over there. So I've got cosine y dy dx minus, when I move that from this side to that side, it's going to change to a minus x dy dx equals, that y stayed where it's at, so it's a positive. This 1 subtracted across, so it's y minus 1. All right, so once again, there we have that common factor of dy dx we can take out. And that's going to leave us with cosine y minus x is equal to y minus 1. All right, and then of course to finish solving for dy dx, all we're going to do is divide by the cosine y minus x. So dy dx is equal to y minus 1 over cosine y minus x. And that's all there is to it. It's not that difficult. You just got to make sure you keep things straight. Remember all your special rules and do some algebra. That's all it is just algebra. Once we get past that first step of the differentiating each part, it's just rearranging it with algebra. All right, so this question says find the equations of the lines tangent and normal to the curve x squared minus xy plus y squared equals 7 at the point -1, 2. Now, first things first, let's talk about tangent and normal. We know what tangent lines are. Let's say we've got this curve here, and we go in and we've got a tangent line. Well, a tangent line is just going to touch at one point. And that was not the color I wanted on that. Let's change it there. All right, so the blue line there is a tangent line. Now, if we go and we want to look for a normal line, what we're going to look for with a normal line is it's going to be a line that is going to be perpendicular to the tangent line at the point of tangency. So let's say that we had gone in here and we saw that, and this is not right because this is not exactly where it needs to be. Let me see if I can move that over and make it a little better, a little more accurate. There we go. That's probably better. All right, so let's say that is my point of tangency. That's where this tangent line touches that curve at that one point. So this has the slope of the curve at that point. Well, the normal line is just going to be perpendicular to it. That's what we end up with there. So let me change that back to blue like I wanted it. All right, so the blue line is the tangent line, and the green line is the normal line. Well, what do we know about tangent lines and normal lines? What do we know about if they're perpendicular? What do we know about their slopes? Well, if you remember, we know that if the slope of, let's say, the blue line is 1/3, the slope of the perpendicular line would be -3. Because it's going to be what? The negative reciprocal or the opposite reciprocal of the slope. So you're going to flip the fraction over. If it's not a fraction, make it a fraction. And then change the sign. That's how you find what the slope of the perpendicular line is going to be. So if we can find the slope of the tangent line, which by the way is the derivative of this thing at -1, 2, we can find the slope of the perpendicular line by simply doing this changearoo thing here. Flipping it over and changing the sign. So let's go ahead and get ready with that. So let's go ahead and implicitly differentiate this. Now we kind of know what we're looking at. We don't need this anymore. So if we take the derivative of this implicitly, we're going to get 2x minus, and in here we're going to have to do the product rule again. So first times the derivative of the second plus the second times the derivative of the first plus the derivative of y squared, which is going to be 2y dy dx, and the derivative of 7, which is, of course, 0. So now we want to solve this thing and find what dy dx is. Everything's already on one side. We do have to distribute this negative through, but other than that, we're okay. So we've got 2x minus x dy dx minus y plus 2y dy dx equals 0. So let's move everything that does not have a dy dx to the other side. So we have, and I'm going to rearrange these while I'm at it. I'm going to put the positive out front. So I get 2y dy dx, that positive term that has the dy dx, minus the negative term that has the dy dx, x dy dx, equals, and when I move these over, the 2x is going to become negative and the y is going to become positive. So I end up with y minus 2x. All right, so then I've got my common factor here that I can factor out of these two terms of dy dx. And that's going to leave me with 2y minus x equals y minus 2x. And then, of course, to finish solving for dy dx, I'm just going to divide both sides by 2y minus x. So dy dx is equal to y minus 2x over 2y minus x. So there is my slope for every single stinking point on the entire graph. Now what I want is I want to know what the slope is for the tangent line at negative 1, 2. So I'm going to move this up here, and I'm going to find, let me go ahead and change colors here. So dy dx at negative 1, 2 is going to equal, and all I'm doing is I'm going to plug in my x and my y everywhere I've got an x and a y here. So I'm going to have 2 minus 2 times negative 1 over 2 times 2 minus negative 1. Let me rewrite that. Minus negative 1. All right, so when I solve this, 2 times negative 1 is negative 2. 2 minus a negative 2 gives me 4. And 2 times 2 gives me 4, plus 1 gives me 5. So my slope of the tangent line is 4/5. Now, not only do I know what the slope of the tangent line is, I also know what the point is that I'm going through here. So to write the equation of the tangent line, I'm going to put this in point slope form. If you don't remember, that's y minus y1 equals m times x minus x1. Where the x1 and the y1 are the point that it's passing through, and m, of course, is the slope. So when we put that in, we're going to have y minus 2 is equal to 4/5 times x minus a negative 1, which means x plus 1. Don't go any further than that. Leave it just like that unless you absolutely are specifically told to put it in some other form or to simplify it further than that. Point slope is perfectly okay for leaving it as just like that, because you guys will make a mistake somewhere along the way and it'll cost you points. Leave it like this unless you absolutely are given instructions to put it in some other form, or if it's a multiple choice question and you have to put it in some other form to match it with the choices. So there's my tangent equation. And here's the neat thing. How do you find the normal equation? Well, remember, if this is the slope of the original one, what is the slope of the perpendicular one? Well, flip it and change the sign. So instead of 4/5, it's 5/4. That is a negative. All right, and then to write the equation of the normal line, all you have to do is put that in place of the slope. Everything else is staying exactly the same. Remember, they're going through the exact same point. So you get y minus 2 equals negative 5/4 x plus 1. Now, if this had been a multiple choice question, your multiple choices may be in slope-intercept form, so you would have to adjust those and redo those. But if they don't, if you do not have to rearrange them into some other form, then you leave those exactly like they are. Don't do any work that you don't have to. And you can, that is the equation of a line, so you've given them what they've asked for. And by the way, there is the equation of this thing right here, and there is the tangent line, and there is the normal line. And there they are in slope-intercept form, but you don't actually have to do that, just in case you're curious. Notice here and here we've got the correct answers. All right, now we're also going to talk about higher order derivatives. Now what that means is that, remember, when you take a derivative, you're finding the rate of change of whatever you took the derivative of. But there are instances where you're going to need to take multiple derivatives. You'll take the derivative of something you've already taken the derivative of. We actually saw this already when we were talking about the particle motion in section 4. But we can do this also with implicit differentiation. So it says find d squared y over dx squared, and if you don't remember that notation, that is the notation for the second derivative. So we're going to find the derivative, and then we're going to take the derivative of the derivative, and that's going to be what we're looking at. So find d squared y over dx squared, or the second derivative of y with respect to x, if 2x cubed minus 3y squared equals 7. All right, so let's go ahead and start this. We've got to find the first derivative before we can worry about finding this second derivative. So let's go ahead and differentiate this implicitly. So you're going to end up with 6x squared minus 6y dy dx equals 0. All right, we have the 1 dy dx. We're going to move everything else over to the other side. So we get negative 6y dy dx is equal to negative 6x squared. Divide both sides by negative 6y. So dy dx is going to equal negative 6x squared over negative 6y, which means that it's going to be x squared over y. All right, so that is the first derivative. So now to find the second derivative, we have to take the derivative of this thing. So let's move over here, and I'm going to change colors just so you don't get them mixed up. And we know that to find the derivative of this, we're going to end up with d squared y over dx squared. That's the notation of the derivative of dy dx. And we have to take the derivative of this. Well, that's a quotient. So you're going to have to use the quotient rule with implicit differentiation. So bottom y times the derivative of the top times 2x minus the top x squared times the derivative of the bottom, which is going to be 1 dy dx all over the bottom squared, which is y squared. All right, so looking at this, we're sitting here and we're saying, okay, well, y times 2x, I can go ahead and write that. So d squared y over dx squared is equal to 2xy, simplified down. And then here with the x squared dy dx, well, what are you going to do about that thing right there? Well, here's the neat thing. You already know what dy dx is. It's this thing right here. So you could go and put x squared over y in place of that. In place of the dy dx, just put x squared over y. So then when we go and we simplify things, we've got x squared times x squared over y gives us minus x to the fourth over y all over y cubed. All right, now we need to simplify this thing down. We don't need to leave that y on in the denominator of the numerator. We don't need to have fractions inside of fractions and stuff like that. Typically, that's something you're going to have to fix. So we need a common denominator between these two. So we're going to multiply this thing right here by y over y. And that's going to give you 2x y squared over y minus x to the fourth over y all over, that's supposed to be y squared, not y cubed, y squared. Now we can combine these and put them together over one common denominator. So we end up, let me move over a little bit here, 2x y squared minus x squared over y. And we're still dividing by this y squared right here. But the thing is, if we're dividing by y squared, that's the same thing as doing what? Multiplying by the reciprocal, 1 over y squared. So if we multiply by the reciprocal, we can simplify this down, boom, and get one fraction with no problem. So we've got 2xy squared minus x squared over y times y squared, which is y to the third. All right, so once you've gotten to that point, if you needed to find what the actual slope is, you would just plug in, you'd take your point that you're finding and plug in your x and your y wherever you need to. But that is d squared y over dx squared. All right, and that's just a little weird. They went ahead and divided it into the two parts. If you go back and look at the work there, let's go back here. If you look at this right here, if I divided y cubed into the 2x y squared, I would end up with 2x over y and an x squared over y cubed. That's what they get right there. That's what they've got. So it's the same value, it's just a little different. Notice they use their notation of y double prime. It doesn't matter if you use y double prime or d squared y over dx squared. All right, that's all of implicit differentiation.